Now we start the next article, properties of reciprocal lattice. Here we discuss some important properties of reciprocal lattice. The first property is that reciprocal lattice is a direct lattice. That is, vector A star bracket star equal to vector A. This term we prove in the next slide. Second one is the volume of unit cell of reciprocal lattice is inversely proportional to the volume of unit cell in the direct lattice. You know volume of unit cell in the reciprocal lattice, that is vector A star dot vector B star cross vector C star. This is the volume of unit cell. That volume is inversely proportional to volume of unit cell in the direct lattice. Volume of unit cell in direct lattice is vector A dot vector B cross vector C. Both these volumes are inversely proportional to each other. That term we also prove here. Next, every reciprocal vector is normal to the plane of crystal lattice. That is, reciprocal lattice vector D star HKL dot any direct vector in a given plane, that is vector C, and dot product of the two vector is always 0. That term we prove under this property. Next property is the magnitude of reciprocal lattice vector is equal to reciprocal of interplanar spacing in the real crystal lattice. There is magnitude of reciprocal lattice vector, that is mod of D star HKL must be equal to 1 by DHKL. That term we also prove under that property. Next property is the unit cell of reciprocal lattice need not be parallelepiped. This is called as brilliant zone, or it is also called Wigner-Sage cell, that we see the next detail about the brilliant zone we discuss in the next article. Next property is each point in reciprocal lattice represent the particular set of parallel planes of the direct lattice that interpret the diffraction phenomena in a crystal. And last remaining one, the simple cubic lattice is its own reciprocal. Similarly, BCC and FCC lattices are reciprocal to each other. Now these are the important properties of reciprocal lattice. Here we prove few of these properties in detail. The first property we prove here, that is reciprocal of reciprocal lattice is a direct lattice. For that we use reciprocal lattice vector, and if defined in terms of direct lattice vector, that term is vector A star is equal to m times B cross C divided by A dot B cross C. M we defined earlier, where M is the scale factor or magnification factor. That scale factor take any value. That if we take M equal to 1, that simply we choose M equal to 1 for X-ray diffraction experiments, or in other case we write 2 pi. Here we choose m equal to 1. Therefore, the vector A star is equal to B cross C divided by A dot B cross C. Then we take the reciprocal on both sides of the equation. Therefore, the equation becomes vector A star bracket star equal to other side is B cross C divided by A dot B cross C. Take the bracket star and simplify this bracket star. The equation term becomes B vector B star cross vector C star divided by vector A star dot vector B star cross vector C star. That term we simplify by using the identity. As you know, vector A star dot vector A is always 1. If we multiply vector A star dot A on RHS side of the equation, here multiplied by 1. Instead of 1, we choose vector A star dot A, since vector A star dot A is 1. Therefore, instead of 1, we multiply RHS side by this term. The equation rewrite as vector A star bracket star is equal to vector A star dot vector A into term is as it is vector B star cross vector C star divided by vector A star dot vector B star cross vector C star. Now the numerator term is A star vector A star dot bracket B star cross C star. Denominator term is same A star dot B star cross C star. Numerator denominator term cancel and the remaining term right here, that is vector A. Therefore, we get vector A star bracket star equal to A. This reciprocal of reciprocal vector is a direct vector. That we prove for A star. Similarly for B star vector, if we take again the reciprocal of the reciprocal lattice vector and we simplify in the same manner, B star bracket star equal to vector P. That time we choose vector B star, that is vector C star dot vector A star divided by vector A star dot vector B star cross vector C star. That represent vector B star bracket star. Now if we simplify in the same manner by using the identity B star dot B, that is 1, that we multiply on the RHS side and numerator denominator term cancel, we get the remaining term vector B star bracket star equal to vector B. Similarly, we write directly vector C star bracket star equal to vector C. This proves the reciprocal of reciprocal lattice is a direct lattice. In that property, we also find the relation between direct lattice and reciprocal lattice. We find earlier vector A star equal to B cross C divided by A dot B cross C. But if we take vector A equal to, what is the term? That we substituting here. Here, vector A star bracket star, that vector A. Therefore, instead of that one, we put directly vector A equal to, other side is B cross C divided by A dot B cross C bracket star. Simplify this bracketed term and we get vector A is equal to vector B star cross vector C star divided by vector A star dot vector B star cross vector C star. That also proves the relation between direct lattice vector and reciprocal lattice vectors. Similarly, vector B equal to vector C cross vector A star divided by vector A star dot vector B star cross vector C star, and vector C star equal to vector C equal to vector A star cross vector B star divided by vector A star dot vector B star cross vector C star. Now we prove the another property. Here we prove another property of the reciprocal lattice, that is, the volume of unit cell of reciprocal lattice is inversely proportional to volume of unit cell in the direct lattice. For that, we firstly note the volume of unit cell in the direct lattice, and it is vector A dot vector B cross vector C. And volume of unit cell in the reciprocal lattice is vector A star dot vector B star cross vector C star. That volume of unit cell in the reciprocal lattice we write in terms of direct lattice. Therefore, the one side we keep volume of reciprocal unit cell, that is vector A star dot vector B star cross vector C star. Put the values of vector A star, B star and C star on the other side, and this is the simplified term. Vector A star is B cross C divided by A dot B cross C. Vector B star is C cross A divided by A dot B cross C. And vector C star is A cross B divided by A dot B cross C. Here we simplify this term by keeping one term outside, that is A dot B cross C. This is the product of three terms. We keep on the ones outside the bracket, and we rewrite 1 divided by A dot B cross C bracket cube inside the bracket B cross C dot C cross A cross B. Now we simplify the cross product of the two bracket firstly, and then again simplified. 1 divided by A dot B cross C bracket cube is as it is. B cross C also keep as it is. The cross product of the two brackets simplified as C dot A cross B A minus A dot A cross B C. Here B cross C dot total bracket. Now this B cross C multiply inside 1 and again simplify. 1 divided by A dot B cross C bracket cube inside the bracket B cross C dot. Inside the bracket is C dot A cross B A minus second term B cross C dot A dot A cross B C. But the second term inside the bracket is 0. Since A dot A cross B is 0, therefore total term we keep 0. Only we simplify the first term. Therefore, the simplified term we write here 1 divided by A dot B cross C bracket cube inside the bracket. This A we take outside. A dot B cross C. This term is as it is. C dot A cross B. Second term is 0. Therefore, in the numerator, the two term product we write both are volume of the unit cell A dot B cross C or C dot A cross B, both represent volume. Therefore, numerator term is A dot B cross C bracket square divided by A dot B cross C cube. Here numerator denominator term simplified and remaining term we write 1 divided by A dot B cross C. It represents the volume of unit cell in the reciprocal lattice, that is A star dot B star cross C star, is inversely proportional to volume of unit cell in the direct lattice, and this is the proof for that property. The next remaining property we explain in the next lecture. Thank you.